So we're going to look at section 2.4 today, which we're getting into something called infinite limits and how that relates to vertical asymptotes that you studied in pre-calculus. Be sure that your cell phone is put away so you are not distracted. You have your notes out, you're writing these down, and you're paying close attention to what we're talking about. It's a short video. Suppose that f of x increases or decreases without bound. So in this example here, we're looking at a graph where the function increases as x approaches 2 from the right, and then it likewise decreases as x approaches 2 from the left. We've previously said that the limits for these examples when we increase or decrease without bound, when it's unbounded, that's a situation when a limit does not exist. Well, we're going to refine that a little bit further now, and we're going to call these infinite limits. And you can tell me that as x approaches that number, the function values get bigger, infinitely bigger, and say it goes to infinity, or infinitely smaller goes to negative infinity. Here's what I mean. As x approaches 2 coming from the left side, so that's what this notation means, is from the left, this graph goes down, and it's just going to keep on going down to negative infinity for the y values. This plus sign right here means as x approaches 2, only looking at it from one side, from the right. So these are called one-sided limits. This is going to be unbounded. It's just going to keep on going up, and the limit would be positive infinity. And you can see in this table of values what's happening as x approaches 2 from the left. So this is the limit as x approaches 2 from the left. So these values, negative 6, negative 30, you can see negative 3,000 right here just to the left of 2. They get infinitely big, or infinitely small, I guess, without any bound. They just get bigger and bigger. And then on the other side, we're looking at it as x approaches 2 coming from the right, and the opposite happens. You notice these values for y just get bigger and bigger and bigger without bound. So these are now going to be called infinite limits. A limit in which f increases or decreases without bound as x approaches a is an infinite limit. And that's the term we're going to go with. So if this comes up now, and it's in the past we would have said d and e, now if it's infinity or negative infinity, go ahead and tell me that in your answers. Let's look at this example. So we've got the graph of 1 over x, so that's the function that we're looking at here is 1 over x. And it says, what is the limit as x approaches 0? Now, it's doing something different from each side. So look at it as x approaches 0 coming from the left side. That's what the little negative sign means. Notice what's happening. The graph as x approaches 0, 0 is this way. Right here, as we approach from the left, we're coming from this direction. Notice that the graph goes down this way. So we would say that the limit is negative infinity. And then as we approach from the right, so as we approach x equals 0 from the right, that's coming from this direction. Notice that this goes up unbounded to positive infinity. Now, what is the overall limit? The case that does not exist so let me back up, let me say that again. We said previously that they have to be approaching the same thing from the left and right. That still holds true. So because the left side is negative infinity, the right side is positive infinity, the overall limit as x approaches 0, we would say, is still d and e because they're doing opposite from both sides. And that still holds. They have to be approaching the same direction or same number from each side. In contrast, look at this example. We're looking at the limit as x approaches 1. So if I said to you, what is the limit for this function that's pictured to the left there, as x approaches 1 coming from the left, so that would be, here's 1 by the way is right here, that would be coming from this direction. Notice that we're going to positive infinity. And if I said to you, what is the limit of this same function as x approaches 1 coming from the right, so that would be from this direction, notice it's the same thing. It still goes to infinity. So because those limits are the same, the overall limit would be infinity. If they are opposite, though, we still say d and e, just like we did in that last example. Now, one thing I want you to notice is that in both of these, as x approached 0 and as x approached 1, we had a vertical asymptote. And you may remember from previous math courses, your teacher said a vertical asymptote is a line that a graph gets really close to but never quite touches. That's not entirely true. You can actually cross a vertical asymptote at some point. Officially, a definition of a vertical asymptote, as we noticed here, so we had a vertical asymptote at x equals 1, and here in this example, we had a vertical asymptote at x equals 0. When we have these infinite limits, that's what creates the vertical asymptote. So we would say x equals a is a vertical asymptote of the function if the limit as x approaches a for that function, if that limit is positive or negative infinity, that tells us that we have a vertical asymptote at x equals a, and that's what we saw in those two examples. We can still find vertical asymptotes by looking at things where the denominator equals 0, and we may have seen that. So in this example, 1 over x, notice that x equals 0 is where the denominator would equal 0, and that still allows us to find vertical asymptotes. In this example, the denominator, x minus 1 squared, if we looked at where that would equal 0, it would have occurred at 1. That would have made the denominator 0, and that was a vertical asymptote. So we can still find the vertical asymptotes by setting the denominator equal to 0, but officially what makes it a vertical asymptote is that it fits this definition. As x approaches that number, the function is unbounded either in the positive or the negative infinity direction. And we'll take a look at a few of these examples in class tomorrow.